Hello guys and welcome. I hope that you're well. My name is I play 4K, aka I play 8K, aka I play 16K or UHD King. I was the first YouTuber that showed you guys 16K resolution gameplay back in 2015 on a 4 Titan X Maxwell GPU architecture that was running 8K resolution screen native with DSR, modified DSR drivers by NVIDIA up to 16K resolution natively rendered and then downscaled to 8K resolution. Anyways, today we're not going to talk about that. Today we're going to talk about Battlefield 3 running on 8K resolution screen natively and with the help of two Titan RTX video cards during GPU architecture running in SLI, two of them, and two Xeon's E5-2699v3 CPUs. Okay, so let me zoom in and show you. During this video I'm going to show you two different levels. So I'm going to start with the ultra preset. This is our ultra preset, okay, and instead of I'm going to turn down the anti-aliasing, and I'm going to turn down the anti-aliasing post and motion blur. This is how we're going to do it, okay. 8K resolution, so pretty much ultra without the anti-aliasing. Let's go ahead and get going. I'm gonna campaign, I'm gonna replay the mission, click OK. We're going to start with the second mission, which is the Operation Sword Breaker. The purpose of this video is not the gameplay. The purpose of this video is to benchmark this system, and this is not my gaming rig, guys. This is a workstation 2021/2022 for low budget folks, okay, and that I built for you. And pretty much I'm doing the 3D rendering on it in 3ds Max with all 72 logical cores utilized and 8K resolution video encoding through FFmpeg++ application. This is going to be a video encoder, video editor application that I'm developing. It's going to be open source, based on open source, but it's going to be for the users as an application, not as a library, which is FFmpeg open source library. So as you can see, this scene can be used as a benchmarking because there is a lot of static going on over here, camera, and I'm not moving the camera right now, so pretty much same angles can be used as a benchmark. As you can see, above 100 FPS, very nice. Latency delay in ms, which is the milliseconds, below 10 milliseconds right now, as you can see. Okay, at the left top corner, data is self-explanatory, but we're going to go ahead and go over it throughout it. So I'm going to show you two different levels. I'm going to show you Operation Swordbreaker, and I'm going to show you going hunting, the airplane mission, which will be the fourth mission in Battlefield 3. Not the third one, but the fourth one. Okay, look how beautiful everything is. And as again, the purpose of this video is not to show you the maximum possible FPS. The purpose of this video is to show the people how two Xeon E5-2699v3 enterprise CPUs behaves in Battlefield 3 and in 8K resolution with the modern video cards, because Xeon E5-2699v3 CPUs was from 2015 and they're equal to 5000 series by Intel desktop CPUs. Okay, during this video I turned down pretty much 14 cores per CPU, because each Xeon E5-2699v3 CPU comes with the 18 physical cores, and when the hyper threading technology is enabled, it's doubled. So pretty much it's going to be 36 logical cores per each CPU, so total will be 72 logical cores output. But it's not a great idea to use it in games because Xeon E5-2699v3 CPU is not overclockable, especially when it's running in dual socket motherboard, when two of them are running in the same motherboard. So just like I'm doing it today. So what I did, I unlocked only 4 cores and disabled 14 cores in the BIOS per CPU. It's possible in the BIOS. I'm running it on a beautiful Chinese motherboard that cost me $110, and each Xeon E5-2699v3 CPU cost me $125 in 2019, in the end of 2019, no, in 2020, actually, in the middle of 2020. Yes, so $250 total for CPUs and $110 for motherboard. I will go ahead and include a great sellers, guys, on Amazon in the video description. Go ahead and check it out where you can buy this motherboard. We're going to modify that motherboard. Yes, I know that you can modify the motherboard BIOS and unlock the maximum frequency for Xeon E5-2699v3 CPUs. Otherwise, when it's running 18 physical cores or 36 logical cores, total 72 logical cores for 2 CPUs, it's only running 2.8 gigahertz in games and 2.4 gigahertz when you're utilizing 90% of the CPU cores. Okay, which doesn't make sense because a PC games likes frequencies, keep that in mind, and the higher frequency the better, or instruction per core and the frequency, because basically frequency is going to be on top of the instruction per core because the higher frequency is better, and then instruction per core, and then the cores. But as again in PC games, the best way will be frequency and instruction per core, and as a workstation, because this is workstation, the cores will be a king. Okay, beautiful Battlefield, looking beautiful, as you can see. As again, the purpose of this mission is not a gameplay, but to test and benchmark. So folks who's looking to build Xeon E5-2699v3, let's say as a workstation, they can do it and they can play games, because I'm going to demonstrate you that you can play games without any issue. This is a great scene over here because it's going to be a lot of 3D geometry over here. A lot of polygons will be pushed through the GPUs. Each Titan RTX video cards based on Turing GPU architecture by NVIDIA has 24 gigabyte of VRAM, which is the video RAM, or 24,000 megabytes of VRAM. Alright, so this is volumetric particles right here, and the most stressful condition for the GPU, and it's running beautifully, as you can see. We ate a lot of FPS, consumed a lot of FPS while doing so, but it's running great. I'm loving it. Okay. Alright, so coming back, as you saw, my FPS started with 100 and then went kind of average 90 and above 80. The YouTuber, another YouTuber, which is Bank4Buck PC Gamer from UK, ran this test in 8K resolution Battlefield 3 with the NVIDIA RTX 3090 video card and Ryzen 5950X CPU, and somehow his FPS was below 80 all the time. And so if I'm outperforming his gaming CPU, because his gaming CPU from 2020, which is Ryzen 5950X, I'm so glad. And this is pretty much will be almost the fastest possible scenario. The fastest possible scenario for the Xeon E5-2699v3 will be 3.6 gigahertz, but without modifying the BIOS. But I'm going to show you how to modify the BIOS in the next videos over the UHD King. But without the modifying the BIOS, pretty much you cannot overclock the CPU, and pretty much you cannot overclock CPU at all. But modifying the BIOS, you can boost it to 36 multiplier, which is 3.6 gigahertz. Each core for all the 72 logical cores will be 3.4-3.6 constantly, and you don't have to shut down the cores in the BIOS. But this is, let's say, if you're going to get any type of motherboards and that BIOS is not modifiable, what you can achieve, okay, on stock without any modification, just through the BIOS as a regular user. So as I showed you guys, ultra preset without the anti-aliasing and without the motion blur, but still with the ambient occlusion. So what we're gonna do now, just because this is UHD King, I'm going to show all kind of presets, all kind of visual presets in the Battlefield 3 PC game. So what we're gonna do, we're gonna turn down the ambient occlusion, because in 8K resolution and above, ambient occlusion is kind of stressing about 10% of the FPS on a Turing GPU architecture and video cards, flagship video cards such as Titan RTX or RTX 2080 Ti video card, which will be similar to Titan RTX video card, but RTX 2080 Ti video card will show you about 10-15% less FPS. Please keep that in mind. I own both Titan RTX SLI and two RTX 2080 Ti SLI, but today we're watching two Titan RTX video cards in SLI. Alright, ambient occlusion is off. Let me go ahead and save it and zoom out. As you can see, I'm zooming in because the Battlefield 3 PC game has a lack UX lag, which is the user interface, not scalable, and kind of so small in 8K resolution, and in 16K resolution and just everything is so small. By the way, I recorded 16K resolution over the UHDking.com. Go ahead and check it out. Beautiful video. Battlefield 3 in 16K resolution on this system. Alright, so what we're gonna do, we're gonna restart the mission. Okay, so this is going to be 8K resolution ultra preset without the anti-aliasing and without motion blur and without the ambient occlusion. Okay, as you can see, introduction video is preloaded, so we're gonna skip it because it's a video. It's not based on 3D engine. You don't want to bench on that preloading video. Guys, the FPS that you're gonna see right now is going to be so amazing. It's going to be unbelievable. And I'm going to write to Bing for Bach PC Gamer from UK, and I will let him know that I bet his 5950X dominated pretty much his 5950X in this test. I want to see what he's gonna say. Go ahead and let him know as well. Above 120 FPS average, as you can see, and latency delay below 10 milliseconds. When latency delay below 10 milliseconds, the gameplay without any stuttering at all. It feels just like single video card. If I'm gonna put you on this system and I'm gonna tell you, look, it's not SLI, you will never let me know that it was SLI. When the latency delay below 10 milliseconds, you're gonna start receiving some stuttering when your latency delay will be 30 milliseconds and above, and at 40 milliseconds and above it will be a little bit of stuttering and the gameplay is not going to be comfortable. The best scenario will be for the latency delay in terms of that milliseconds, which is ms at the left top corner, below 5 milliseconds. It's crystal fast when you're gonna do it. It's just unbelievable how fast it is. Check it out, guys. 120 FPS at ultra preset 8K resolution with 2 Titan RTX video cards and the workstation CPUs from 2015. That is not even gaming CPUs, because even in 2015 Xeon E5-2699v3 was very slow for gaming. As again, if you did not use the scenario and strategy for PC games as I'm using today, if you did not shut down the cores, and YouTubers and reviewers on YouTube and benchmarkers do not shut down the cores, and this is a big mistake. You want to shut down the cores, so you're going to share that level toward CPU cache. So right now pretty much 45 megabyte level toward CPU cache per 4 cores per CPU. So total output is 8 cores and 90 megabytes for those 8 cores. Keep that in mind. So almost 10 megabytes per each core level toward CPU cache. That helps a lot, as you can see, especially when I'm higher FPS than Ryzen 5950X. Keep that in mind. So if I'm going to run this 2 Xeon E5-2699v3 from stock, they're going to run 2.8 gigahertz in games and 2.4 gigahertz when 90% CPU cores will be loaded. Okay, but we're gonna fix it through the BIOS modification. But before that, I need to test it first and benchmark it, so you're gonna see it yourself. Beautiful. I'm so in love with this workstation, guys. This is the best $400 that I invested. So pretty much $250 for 2 CPUs, $125 per each CPU from the local e-recycler company, and $110 for motherboard. Unbelievable. I'm running today 172 gigabytes of system RAM. Okay, so we have plenty of RAM. As you can see at the left top corner right now, my video RAM, which is VRAM usage, will be 66,000 megabytes, which is 7 gigabytes almost, and the system RAM usage will be almost 11,000 megabytes, which is 11 gigabytes. You can see it at the left top corner. The frequency per each core 3300 megahertz, because it's running 33 multiplier. The scenario for the Xeon E5-2699v3 CPUs will be 1 or 2 cores at 36 multiplier, which is 3.6 gigahertz. 3 cores will be 34 multipliers, which is 3.4 gigahertz, and 4 cores will be 33 multipliers, which is 3.3 gigahertz or 3300 megahertz, as you can see at the left top corner. So pretty much, as you can see, I'm showing you, it's beautiful. The game looks so beautiful in this 8K resolution. So pretty much 4-core per CPU for Xeon E5-2699v3 is the best scenario when you need to have a cores and a high frequency, which is 3.3 gigahertz per core. Otherwise, if you're going to do a 6-core per CPU, it's going to be 28 multiplier and 2.8 gigahertz, and pretty much difference will be 400 megahertz, and I would say it's about 1 FPS difference. Okay. You can run the Battlefield 3 in 8K resolution with just 6 cores, 6 threads, okay, and without the bottlenecking. It will be like 80% utilization on the CPU. When CPU utilization, as you can see at the left top corner, overall CPU utilization is below 90% and never reach above 90%, that means that you don't need to have any additional cores. You're not going to boost up. Look at this, volumetric particles, and it's eat up some FPS, but we still very high FPS. This is just unbelievable. Alright guys, so I'm going to go ahead and reboot now. We're gonna switch the video resolution, video settings. Absolutely amazing. It runs so fast, guys. There is no lag at all with 2 Titan RTXs. I remember in 2016-2017 when I was running Battlefield 3 on 4 Titan X Maxwell GPU architecture, which is 3 generation before Titan RTX. With 12 gigabyte of VRAM, it was stuttering. 4 of those video cards, it still was stuttering in 8K resolution, just a little bit, because due to latency delay. Right now, as you can see, our latency delay below 10 milliseconds almost all the time, but on the 4 Titan X Maxwell GPU architecture, the latency delay was like 40 milliseconds, and as I told you, it's stuttering above 30 milliseconds. But if you don't want to have any stuttering, you want to have 10 milliseconds or below 5 milliseconds, as again, it just rocket fast. Alright, so let's go ahead and apply now completely Ultra. I'm going to show you all kind of presets, guys. That makes sense. So Ultra with 4 times MSAA and high anti-aliasing post, and motion blur is on, and ambient occlusion is on, HBAO. We're going to save that. Okay. Save it. Double save it. Okay. And we're gonna restart the mission. Guys, please watch this video in 8K resolution, but at least in 4K resolution. I'm going to upload this video in 8K resolution. I'm recording this video today with NVIDIA Shadow Play software. It's not the external professional video equipment. It's NVIDIA Shadow Play software that pretty much is utilizing some resources of the same system that I'm running this game right now in 8K resolution. So please add 3 FPS to the FPS counter. So when you're not recording, it's going to be 3 FPS higher than right now. So just add 3 FPS whatever you look at the left top corner at the FPS, add 3 FPS, and this is without recording. Please support my YouTube channel, guys, and share it with your friends, subscribe, post it over some forums and such. And I'm going to collect those pennies, visiting my sponsors as well. I'm going to collect those pennies, and I'm going to purchase the 8K resolution professional video encoder equipment, because my Chinese version from the late 2016 8K resolution video recording equipment burned out. So only using right now the Shadow Play, and we don't see the real FPS. But as again, to see the real FPS, just go ahead and add 3 FPS. Titan RTX right now using the NVIDIA stock air cooling with dual fans, and they're running 100%, as you can see at the left top corner, constantly 100%. And we can see that the first video card closest to the CPU is bottlenecking. Not the bottlenecking, but thermal throttling, which is decreasing the frequency because it's at 86 Celsius. It's so hot. So that's why the Titan RTX is right now running stock, because when you're using both of them on air in SLI, pretty much the first one closest to the CPU will be thermal throttling. Okay, so it's a great idea to put the hybrid water cooler on the first video card at least, and invest about $110, so you can overclock Titan RTXs to 2000 megahertz per GPU core, and 2000 megahertz additional for the VRAM, and the boost will be at least 10%. So whatever you see right now, it's 50 FPS average plus 10% boost, which 5 FPS, so 55 FPS will be right during this preset. Okay, otherwise it's thermal throttling, as you can see, but it's still very high FPS. Okay, I'm using this system as workstation for 3D rendering. I'm using 3ds Max 172 logical cores fully utilized at 100%. And this is exactly what I'm benefiting. You don't want to buy the system exactly for games, keep that in mind. If you just gaming, most likely you want to buy the gaming CPU, but this is my secondary computer that I'm using as workstation while doing some 8K resolution video for YouTube. Very fast. It's outperforming my i9 9900K at 5.3 gigahertz easy, and my i9 9900K by Intel is a gaming CPU. And I'm going to show you my gaming rig with i9 9900K overclock at 5.3 and at 5.4 in 16K resolution. I recorded the Battlefield 3 in 16K resolution. Go ahead and check it out over the UHD King on this system on a single Titan RTX and with 2 Titan RTXs for those naysayers, just to demonstrate that SLI is giving you 1.9 times boost and sometimes even 2x boost versus the single Titan RTX in terms of our FPS. As again, guys, I'm coming in real time. English is not my first language, but I'm doing the hardware since 1996. I'm software developer since 2007, I believe. Web developer since 2000. Graphic designer since 2002. And 3D artist since 2003. So I have a lot of information to share with you guys. Beautiful. So pretty much almost 60 FPS average, ultra with 4 times MSA anti-aliasing, guys. Completely maxed out. And this is 8K resolution. Okay. So at ultra without the anti-aliasing, pretty much I outperform the Bank for Buck PC Gamer from UK. So go ahead and post this video to him, and we're going to have a discussion regarding this because his CPU should outperform my CPU for sure. His Ryzen 5950X, but maybe the RTX 3090 video card is not as fast as 2 Titan RTXs in 8K and above. Maybe the reviewers, those multi-million subscriber watchers, reviewers that pay the reviewers lie to us. There is a possibility. I did not test RTX 3090 versus 2 Titan RTXs yet in a lot of games. I saw a couple benchmarks from my friends, but I didn't test it myself. Okay, so I compared their benchmarks with mine, but I didn't test it physically on the same system. Keep that in mind. My Core i9 9900K overclock at 5.3 GHz with 6 cores, 6 threads, and at 5.4 GHz with the 4 core, 4 threads, of course, will outperform this system by about 10% as minimum in terms of the FPS. So go ahead and add over here 10% more, which will be like 5 FPS to the counter, so it will be 50 if I would be running on my gaming rig, which is Core i9 9900K. But as again, so pretty much self-explanatory. I'm going to show you that video on my gaming rig as well and on some other systems. Okay, yeah, so this is the overall right here. Overall, as you can see, CPU utilization 28%. So you don't need even the 8 cores, 8 threads in 8K resolution for Battlefield 3. Most likely 6 cores, 6 threads will show you the same FPS, and 6 cores, 6 threads will be running 100 megahertz more, but 100 megahertz more is not enough. So I decided to go ahead, not enough even for 1 FPS extra as performance boost. So I decided to go ahead and show it to you guys with 8 core, 8 threads. I know people loving it, even if it doesn't work, but they loving it to see it. But you wanna get with which makes sense and not which, you know, looks great for your bodies. Keep that in mind. I'm always not about the brands, not about what is looking great. I'm always about what makes difference, what performs, about the products. And so far, this is a great system, guys. I'm so in love with this Xeon E5-2699v3 dual as workstation. So my gaming system is sitting there and I didn't use it for 6 months because I'm doing everything on this workstation. It's just a beautiful $400, guys, that I ever invested. And keep in mind that in 2015, each Xeon E5-2699v3 was $5,000. So it's pretty much $10,000 from 2015 just on chip and of those 2 CPUs, and that I invest only $250. Absolutely amazing. All right, let's go ahead and switch it. And so we saw the ultra Of course, with 4 times MSA, the FPS wasn't that great, but it was comfortable. You can play like this online, and you can play like this campaign because it's 60 FPS. So we're gonna go ahead and try the high. High will be still with anti-aliasing post, but without the anti-aliasing deferred. Let's go ahead and try that. Save that. Apply that. Alright, let's go ahead and restart the mission and try it again. And then I'm going to show you going hunting, which will be the 4th mission, just because I showed you that mission before in 16K resolution, 12K resolution, 10K resolution, 8K resolution within the different systems. I'm going to show it to you again. Okay, so you can compare 16K resolution on this system versus 8K resolution and see terms of the FPS and some other information and data throughout the UHD King's videos. Okay, guys, of course you can share my videos over forums, discords, whatever. Go ahead and share them, please, and share it with your friends, liking it, and subscribe. Visit my sponsors, guys. So I'm gonna collect those pennies because I invested into my YouTube channel $40,000, guys, and so far on the ads I even didn't pull the $10,000. So go ahead and support me because I'm investing towards you. I'm going to collect those pennies and reinvest it towards you. So we're going to buy more hardware, and I'm going to test more hardware. Maybe one day I'm gonna get the Quadras with about 48 gigabytes of VRAM. But Quadras cost like used car, each video card. If you think the Titan RTX that cost in 2021 over $4,000 for used video card when it was $2,500 for new in 2019 is a lot of money, well, think again, because Quadras will cost you $8,000-$10,000. And support me, guys, support me visiting my sponsors. Maybe I'm gonna buy it one day, or maybe I'm going to write a letter to NVIDIA CEO, and maybe you will help me, and you will write a letter to NVIDIA CEO, and you will ask him to send me 2 Quadras so I can test them throughout the games and throughout any other benchmarks over the UHDking.com YouTube channel. It's beautiful. The game looks beautiful. Let me go ahead and zoom in, show you how the beautiful game looks. Look at this. This is the zoom. I'm zooming in with the software, not with the game engine. And this is how sharp the details. See that wall right there on the background? If you're playing this on 4K resolution, you're not going to see those details even on 4K resolution. 1080p for sure it's going to be blurred out. Maybe 4K resolution is going to be a little bit of details on that wall from the distance. But pretty much when you're playing 1080p and all the way to 4K, at the distance, details are blurred out. At 8K resolution they're there, and 16K resolution the details will be right there on that brick. Let me show it to you. There is a brick right there. When I'm playing 16K resolution, there is a brick right there. The last brick going to have some details. You see that wall right there that blurred out? When I'm playing 16K resolution, that wall right there is not going to be blurred out. The last wall is going to be detailed as well. Okay, so pretty much 8K resolution and above gonna give you details everywhere at the distance, no matter where you're looking at. Plus, visually it feels like 3D meshes, 3D models, increasing the polygons count, but it's not. It's just a psychological feeling, but it feels like that visually. It looks like that as well. I'm not sure why, especially when you're playing in 16K resolution, the models looking less squarish. Maybe just because it's more pixels to render, and it's kind of makes sense, but it's not the polygons. It's just a pretty much psychological feeling to it, but it looks like that, guys. I'm not sure why, but it's look like maybe just because it's pushing more pixels. 16K resolution is 133 megapixels, while 8K resolution is only 36 megapixels. Keep that in mind. And as again for 16K resolution in Battlefield 3 on this particular system and on the newer systems and all kind of systems, go ahead and visit UHDking.com and check out the 16K resolution playlist over my YouTube channel, and check out my gameplays and videos. A lot of great information. Also check out the 10K resolution and 12K resolution. All right, so how I'm achieving that? So pretty much I modified the drivers and I unlocked the DSR to 16K resolution, and I modified the drivers and I unlocked the shadow play to record in 8K resolution. Okay, can be done through the system RAM debugging tool while modifying the hex. Okay, beautiful FPS. Look at this 88 FPS average. Wow, Look at this, and there is a particles right here. That's why it's 88. If I'm not gonna look at that particles, my FPS will increase. But as you can see, it's not hiding that particle in Battlefield 3 Frostbite game engine. So when I'm going to get in the point of the level when there is no particles, my FPS will go like to above 90 and above 100 FPS, like right now. There's no particles over here, and here we go. So those volumetric particles consumes a lot of GPU performance. It's decreasing the FPS. It requires a lot of GPU computing power, a lot of those CUDA cores. And today each Titan RTX video card featuring 4,608 CUDA cores. It's 125 CUDA cores more than RTX 2080 Ti. And when you're running two Titan RTXs and SLI, it's going to be 250 CUDA cores more than two RTX 2080 Ti and SLI. And this is where it's exactly make a big difference. Look at this, volumetric particles eating up our FPS, but still pretty nice, above 76, 75. That's beautiful. And plus, without the recording, it's going to be like 80, because as again, please add 3 FPS to the FPS counter. It's just beautiful, guys. All right, let's go ahead and switch it, and I'm going to go ahead and go option, video, and I'm going to go ahead and go medium. Guys, I'm going to re-encode this video, so this is going to be a medium preset now. I just switched to medium. Okay, so I'm going to save it. I'm going to re-encode this video with the FFmpeg++ application, video editor, video compression, video encoder application that I'm developing right now, and the file size will be twice less than NVIDIA Shadowplay in 8K resolution, but it's going to be the same quality. And this is why, and when I'm going to enable all the 72 logical cores on those two Xeon E5-2699v3, while FFmpeg++ application that I'm developing will be utilizing all the 72 logical cores. So this particular system is only as workstation for 3D rendering, because 3D rendering such as 3ds Max that I'm using or Blender are going to utilize all the available cores, guys, no matter how many cores you're going to have. And the more cores you have, the faster 3D render per image will go. So let's say if you're rendering 3D animation into video file, it will take you a couple days, but more cores you have, the less time it will take you. Okay, but in PC games, it's different scenarios. It's all about the frequencies per core, and it's all about instructions per core. Okay, the newer CPUs has more instructions per core and even more frequencies per core. So this is not to set the record, this is just to show you that on a low budget $400 workstation you can do anything. And in 3ds Max it's still worse in power, like $2,000-$3,000. Keep that in mind, because I'm outperforming in 3ds Max 5950X CPU with this system, and while it's running stock. But I'm looking to overclock, not to overclock, but kind of overclock this two Xeons by modifying the BIOS. I'm going to create a video tutorial how I'm going to do it on this Chinese motherboard, and also going to record some great videos. And I'm looking to push top, as again, those 72 logical cores at 34-36 multiplier. So all the 72 logical cores will be running 3.4 gigahertz or 3400 megahertz, or 3.6 gigahertz or 3600 megahertz. Beautiful. Look at this medium preset, 95 FPS average, while the first Titan RTX is thermal throttling heavily. It lost about 300 megahertz. And if you're going to set the first video card on a hybrid water cooling system, let's say by investing another $150, then you will be able to overclock your Titans to above 2000 megahertz on a GPU, and additionally you will be able to overclock your VRAM from 14,000 megahertz to 16,000 megahertz by additional 2000 megahertz boost, and it will reflect that in about at least 10% of performance boost in terms of the FPS. So right now FPS 105, so go ahead and add 11 FPS extra, so it's going to be almost like 120 FPS, which is amazing, just by overclocking two Titan RTXs. Or if you're running two RTX 2080 Ti, it's going to be lower by 10%, but by setting it on a hybrid water cooler, as again, no matter what kind of video card you're running on SLI, and Titan RTX, by the way, is the last video card that the last mammoth that you can run in SLI. Keep that in mind, by NVIDIA. And no matter what kind of video card you're running in SLI mode, the first video card closest to the CPU will be always thermal throttling and will be extremely hot in SLI conditions, especially when they're running on air, because there is no much space between two Titan RTXs to breathe. When I'm going to show you in the end of this video this workstation specification within the details, you're gonna see the wallpaper that I took a picture of it, and you will be able to see that there's no such much room to breathe. So pretty much for first Titan RTX, first Titan RTX is breathing the hot air out of the second Titan RTX. Keep that in mind. About 120 FPS average, medium preset, beautiful guys. CPU utilization was 60%. I saw it a couple seconds ago, but never reached above 70. So pretty much 8 cores more than enough, and I would assume that 6 cores will be more than enough. But when 70% reachable on 8 cores, it most likely is going to reach like 88% on a 6 core. But as you can see, it's only like for a half of the seconds throughout the whole gameplay. So we're Gucci. So those particles right there, eating a little bit of FPS. Guys, please watch this video at least on 4K resolution screen. Just switch in your YouTube player to 4K resolution, or I would advise to watch it in 8K resolution, because 8K resolution going to be such a beautiful image quality and such a beautiful video quality that you're gonna love it. All those details you're gonna see in 8K resolution. Alright, let's go ahead and test the volumetric particles in this scene. That's why I love this scene and this level, because over here there is a lot of polygons, a lot of 3D meshes. They all have a lot of polygons in them. There is a lot of characters, and every single character has a lot of polygons in them as well. So this is pretty much the heaviest scene ever, and as you can see with volumetric particles, we're still about 80 FPS average at the medium. Amazing. Alright, let's go ahead and switch it, and now I'm going to show you low preset. Okay, low preset. Here we go, guys. Keep in mind that your field of view should be 90, because field of view 70 or 60 will show you will show you higher FPS by about 1 or 2 FPS, because at 90 field of view, you're pretty much rendering more surface of the direct 3D surface. Alright, so low preset, this is the low preset. As you can see, I'm going to apply, then I'm going to go ahead and say apply again, and we're gonna restart the mission. And after that point, we will be done with the test and benchmarks on this level, and then I'm going to switch to going hunting, as again, just for you to compare with the same system, 8K resolution and 16K resolution, because I recorded a lot of videos in going hunting. Look at this, almost 200 FPS. This is and this is exactly when you need to have the 8 cores, when you're running at low visual presets, okay? Otherwise, when you're running 8K resolution at ultra preset or high preset, a 6 cores extras will be more than enough. But over here at low preset, most likely 8 cores will have a boost a little bit, because at low preset you're using a lot of CPU. But it's not going to be the case in a game that's going to be released in 2022, because the most modern game engines are focused, utilize the GPU and video card first before it's using the CPU and system RAM. Okay, not like it was before, like way in 2010, 2015. Now the modern games is utilizing completely your GPU and video RAM before it's going to touch the CPU and system RAM, unless there is a special calls for CPU and system RAM. Otherwise, it's focused on that video card utilization. Alright, beautiful, 125 FPS. Check it out. All those 3D characters, they having a lot of polygons in them. So this is very heavy scene right here, in terms of the pushing a lot of geometry through the GPU pipeline. and storing a lot of data in the VRAM as well. And it's also the heavier scene for the CPU benchmark as well than going hunting, because going hunting will be more like a GPU focus, more like video card utilization focus, while this scene is pushing a lot of data, so it's utilizing a lot of video card plus the CPU. So I'm going to show you all kind of benchmarks, so you're going to have all kind of data to speculate. Just beautiful, guys. Let me zoom in again. Look at those details. I just zoom in with the software, but this is how it is. In 8K resolution, especially the larger screen you have, the more details you can see as a human being. Of course, if you're going to have 7 inches screen with 8K resolution, doesn't make no sense, because this is going to be the scenario where you're not going to see the details. Those losers on YouTube that they were saying 8K resolution, you're not going to ever see 8K resolution. They were saying that back in 2015, 16, and when I was already seeing 16K resolution, and I was laughing. In 2010, they were saying that we will never need the 4K resolution when I was running for the first time in 2011 the 4K resolution on my 4 Radeon R9 290s in Crossfire. It was 4K resolution, and I believe I tried the 6K resolution, but the FPS was so low back during that time. Beautiful, guys. So we're utilizing almost all the time on average like 60% of our CPU. So 6 cores, 6 threads, as again in 8K resolution will be good enough. But the formula, the algorithm is easy. The higher resolution, the less CPU you're using, and the lower resolution, the more CPU you're using. So the higher resolution, the more GPU you're utilizing. All those 4608 CUDA cores are utilized at 8K resolution right now at 97, above 90% per each video card. This is a great SLI utilization, but not amazing. Amazing SLI utilization will be 99%, 97% I would say. Super SLI utilization will be, look at this, volumetric particles, will be 99% utilization. This is what I consider. But at least 1.85 times faster than a single Titan RTX. And it's going to be individual video, guys, when I'm going to split the screen and compare Titan RTX versus 2 Titan RTXs in SLI in 4K resolution, 8K resolution, 10K resolution, 12K resolution, and 16K resolution in Battlefield 3 game. So it's going to be another great video, but more great content is coming, so stay tuned. And as again, go ahead and subscribe, share it with the friends, and guys liking it, because we're doing it on our own pockets. It's not like Linus that got sponsored to lie sometimes. This is reality, and I'm showing the real facts. I'm not lying like those high school kids that trying to decept you throughout their videos, showing you the video cards that not even for sale. They're just creating the channels and lying to you. But I'm in business since 2007. I started the YouTube with the software that I developed. During that time, it was only Camtasia and Fraps and my software, Ultimate Video Capture, and then I renamed that software. But NVIDIA Shadowplay killed my software, because there is nothing can be compared with NVIDIA Shadowplay, because NVIDIA Shadowplay utilizing the hardware and software, while any other products utilizing only software. Believe me, because as a video capture developer, I know so. So this is what we're gonna do. So this was low. Okay, you saw the FPS. So what I'm gonna do now, I'm going to load. Let me go exit to menu. Going hunting mission, which is the 4th mission, and real quick going to go through that, and then in the end of this video I'm going to show you some information about the system with all the details for those hardware enthusiasts and gurus and overclockers and people that looking to build smart system. But as again, for those people that 3D artists and are going to do a lot of video encoding, and video encoding in the application that's going to take advantage of all the logical cores. If you're playing only games, this is not the system for you. Then you go ahead and watch the video when I'm going to show you on my gaming rig. And of course, I'm gonna test the newer systems. They're all coming out, guys, to YouTube channel, but just because it's single of me, you're not supporting me. Support me, so I'm gonna hire some more folks if you will support me like that, and I'm going to have all kind of great videos. So what we're gonna do, we play mission, and I'm going to real quick start with the going hunting right here. Okay, beautiful. Let's go and have a look at going hunting. It's going to be a lot of airplane ships. It's going to consider a lot of 3D polygons in them as well. So this is a little bit different mission. It's starting with the like no polygons count almost, and then it's going to increase the polygon counts and all the way to the highest possible level throughout this particular mission. Look at this. So it started with 140 FPS, but it's not utilizing very well the GPUs because the low preset. As again, the higher visual preset in PC games since 2010, the better GPU utilization, even since 2000 even, since the PC gaming industry. And the lower resolution, the more CPU utilization and the less GPU utilization. So we're gonna improve our GPU utilization when I'm gonna go ultra for sure, and we're gonna decrease that CPU usage. But I don't care about the CPU usage because, as again, 8 cores, 8 threads, those are physical without the hyper threading at all. So hyper threading is disabled. And as you can see, my data is right. It's not like about those quick buck high school kids that decept you with the fake videos, that putting on top of those fake videos, they putting bunch of numbers that nobody even can tell what those numbers are. Over the UHDking.com, every single videos make sense. And over the UHDking.com, it's not going to be only the PC gaming videos, guys, or PC hardware. I'm going to be into the mobile gaming, into the mobile hardware, such as Apple and Android. I'm going to teach you how to develop games, developer softwares. I'm going to teach you how to be how to create great 3D animation, step-by-step tutorials. I'm going to teach you Photoshop, pretty much everything what you need to know. Alright, 129 FPS. So I saw 144, 129. So you can see the scene. This scene is heavy comparing to the other scene when we tried the low. Okay, because the FPS was lower at this scene than we had over the previous mission. Alright, so this one will be let me go ahead and do the medium. So we did the low, now it's going to be the medium. Oops, let me reload the checkpoint. Here we go. Really love this system, guys. Beautiful system, and beautiful Chinese motherboard, by the way. I'm gonna include the video description in Amazon when I purchase it. And on this motherboard, I'm going to create a tutorial. I'm going to overview this motherboard completely, and I'm going to create a tutorial how to modify or hack this motherboard to unlock 34-36 multiplier on each core with all 18 physical cores per each CPU V3 version Xeon E5s. And this motherboard supports all the way to 72 cores, all the way those whole line, enterprise line of the Xeon E5 V3 CPUs. 2022 Xeon E5-2699v3 will be even cheaper, guys. But as again, they're not ideal for the gaming, but for the low budget folks that using this system as workstation, as everything, like all-in-one system, it can do anything, as you can see. Only in terms of the FPS, you will be like 15%, 15, not 50, but 15% lower. But you're not gonna pay $2,000 for your gaming PC. You're only going to build up this system and pay like $700 without the video cards, including the RAM, DDR4, and as again today I have 172 gigabytes DDR4, pretty much a lot of Team Group and Corsairs. But the motherboard supports 256 gigabytes, but I don't need 256 gigabytes. With 172 gigabytes, I can have 100 gigabytes as a RAM disk to use this system RAM as the storage device, which is 5 times at least faster than any SATA 6 SSDs, okay, and by about 2.5-3 times faster than the fastest possible flash storage device. And this is DDR4, and this is on a 5000 series desktop Intel kind of performance CPUs. With the newer CPUs, the boost will be even on another level. Alright guys, with DDR5. So what we're gonna do now, I'm going to go ahead and switch it. Again, I'm coming real time. It's kind of hard to play and comment and think about the things because I'm not reading it, guys. I'm going freestyle. How I achieve 60 Hz in 8K resolution on Titan RTX. I use the display port 1.4 and the adapter for the HDMI 2.1. Okay. Otherwise, it's supporting 8K resolution at 30 Hz only without the adapter if you're going to use the HDMI port, because the HDMI port on Titan RTX is HDMI 2.0B, 2.0B, and you need to have 2.1 HDMI port version 2.1 to be able to run 8K resolution 60 Hz. Alright, high preset, let's save that. Let's go ahead and load the checkpoint, so it's gonna start exactly where we need it. Look at this, almost 100 FPS. Lowered on the CPU utilization, just like I told you, 47, 43, 42, and I saw at the start it was like 37. So if you're lowering CPU usage in terms of the cores, it's only consuming a lot of that frequency and instruction per core IPCs. This is only what is boosting right now during this type of conditions in this particular game. As we can see at the data left top corner, 3.3 gigahertz or 3300 megahertz, as you can see, not bad. I could show you 6 core output instead of 8 cores, but only 100 megahertz boost. It's not going to give us even 1 FPS performance. So I decided to go ahead and show you 8 cores just to show you what it is. But if I'm going to modify the BIOS, as again I'm going to show you during my UHD King video tutorials how to modify the BIOS of the Xeon E5-2699v3 motherboards, because it's not only applied to this particular motherboard, it's going to apply to a lot of motherboards, especially from China. The method that I'm going to show you how to hack the BIOS of the X99 dual socket motherboard. This is what Chinese calling it, but this is the C612 motherboard actually. Dual socket 2011 v3. Beautiful FPS. So as you can see, first Titan RTX is thermal throttling a little bit, and if it wouldn't do that, we will be even higher than that, but it is what it is, and I'm showing you what is default. Of course, you can modify it the way you want it. You can set 2 Titan RTXs in water, but you're going to invest like $1,000 if it's going to be professional. It doesn't make no sense. Okay, you got to apply the logic, right? Use the intellectual strategies and approaches. But if you want to pretty much have maxed out Titan RTXs, here's the approach. Hybrid water cooler on the first one closest to the CPU. The second one can be an air, because the second one never go above 60, and it's not even thermal throttling at 60 Celsius. It's starting thermal throttling at 62 Celsius during GPU architecture that is powering today our NVIDIA Titan RTX video card. Alright, so high, we saw high. Ultra with 4 times MSAA and anti-aliasing posted high, so this is maxed out. Save that. Let's go ahead and load the checkpoint. Here we go. This is maxed out, guys. Not bad. Above 60. still above 60 without the recording. And this is the comfortable, guys. Even like that scenario in 8K resolution, comfortable completely. When I'm going to compare it with 4 Titan X Maxwell GPU architecture, even at 60 FPS, my latency delay was like cuckoo. It was like 35-45 milliseconds. Okay. So pretty much 2 Titan RTXs is about 3 times faster than 4 Titan X Maxwell GPU architecture and SLI in terms of the latency delay in milliseconds before each frame is rendered. So pretty much it's a delay between the hardware and software. So delay in GPU, VRAM, CPU, system RAM, and then the software, which is the Windows 10 professional operating system that I'm using today, and DirectX 11 API. So it's all in terms of the 17 milliseconds right now. The increase in milliseconds, as you can see, on that level it was like 10 milliseconds. On this level, milliseconds is increased. That's why I like to show you this level, because there is a lot of volumetric particles going on, plus the polygons, as you can see, and plus I already benchmarked this level, so we'll have the data to compare. But that level was also great to benchmark. Over here, just all of this is a static camera, and this can be used as a benchmark. You need to have the static camera view for the benchmarks. Okay, so I showed you ultra maximum visuals. Now I'm going to show you how I'm going to play it. So I would play it ultra, but without the anti-aliasing, because you don't need to have anti-aliasing at 8K resolution, but for sure at 16K resolution it just wastes of the resources. So it's without the anti-aliasing and without the anti-aliasing post, but with the ambient occlusion HBAO. I'm gonna save it, and then I'm gonna explain to you in the end of this video what is the ambient occlusion for those people who doesn't know. Again, guys, I'm repeating myself and explaining for the beginners, so a lot of beginners watching this video, so they're going to understand. Okay, and if you're a pro, you can learn see the data at the left top corner. You even don't need to have an explanation. If you're a pro overclocker or pro PC enthusiast, just like myself. My first computer ever was that I made myself, but the first ever computer that was of my parents was 286, but my own computer was 386, IBM 386, that I built myself back in 1997, I believe, 1996 or 1997, yeah, 1996, 386, my first one. So you can see my experience is like years of lives of some people that are watching this video as well, like entire lives. Alright, guys, look at this. I saw 100 FPS, 90 FPS, above 90 FPS average pretty much, with the ultra preset without the anti-aliasing in 8K resolution with 2 Titan RTX and SLI. This is pretty much, the scenario will be like that everywhere. What I'm gonna do, guys, in the end of this video, I will try to load the multiplayer level as well, just to underline it. We're gonna cool it down a little bit. As you can see, it's thermal throttling. We're gonna cool it down, and I'm going to load the online multiplayer. Alright, so you saw the FPS. So now, let me show you what we're gonna do now. Now I'm going to turn down the ambient occlusion, because ambient occlusion in 8K resolution and above taxing a lot of FPS for Turing GPU architecture. Okay, like on Titan X Maxwell GPU architecture, anti-aliasing processes was taxing a lot of FPS as well, but for Turing it's not like that. But ambient occlusion is taxing as well, like about 15%. 15% of the FPS. So I'm going to turn it down. And what is the HBAO and what is the ambient occlusion? Ambient occlusion, pretty much see those details. Every single 3D model has the edges of that mesh, and what ambient occlusion does, it's just creating that kind of shadow feeling to it, like a darkish kind of gray gradient, and pretty much it's like inner shadow in Photoshop. If you're familiar with the Photoshop, but if you're not, go ahead and sign up for UHDking.com. You're gonna learn the Photoshop. So let me show you what it does. You're gonna see it's gonna disappear. So just creating that extra fakeish shadows, kind of creating like, but it's still fake. So anyways, I would play it without the ambient occlusion, and you can see what it does. Check it out. Enabled. So it's that gradient. It's kind of creating that proportional light into the shadow. Artistic kind of view, but it's still fakeish. Keep that in mind. Alright. So, and it's not too much of the difference, as you can see. It's still, the level's still going to have the shadows. So keep that in mind. So let's go ahead. This is just kind of making it more softer, I would call it. There is a soft shadows, and this is going to be even more softer than soft shadows. Okay. So let's go ahead and save it, and let's go ahead and run it. Okay. And now when you're gonna see the FPS, you will be like, wow, this is just unbelievable. So pretty much we are using right now 45 megabytes of level 3rd CPU cache per each CPU for 4 cores. So pretty much it's like 11 megabytes, something like that, per core. 11.5 megabytes per core per CPU of level 3rd cache. It's a lot of cache, guys, per core, because when you're using all the 18 cores, it's going to split 45 megabytes level 3rd cache for all those 18 cores. But right now we're having more CPU cache per each core, so each core will feel much more comfortable when it's going to be buffering. But throughout the gameplay, throughout the PC games, throughout the 3D games, the new game engines since 2010 are not utilizing pretty much the cache of the CPU that much. They're more focused on the GPU utilization than the CPU utilization. Back in 2011, I played with the C# and DirectX 10, and I developed my own Direct 3D surface and kind of asteroid game. So I learned about the Direct 3D surfaces, and I learned pretty much about the 3D worlds as a software developer, graphic designer, and a gamer at the same time. So that's why I have a lot of information to share with you, and that's why you want to put this channel into your favorite if you into this type of things, if you hardware enthusiast, hardware overclocker, gamer, and want to be like all-in-one IT specialist, IT professional. This is, I highly recommend you my YouTube channel. So guys, you saw it, right? You saw it like that. Let me show you, let me overclock the Titan RTX, and it's going to cool down a little bit because I'm gonna close it. I'm gonna show you the specs, and we will come back and I will try to overclock the Titan RTX, and then you're gonna see that extra 10-12% of the performance boost. So what I'm gonna do, this is what I'm gonna do. I'm gonna zoom out. I'm gonna show you the specs. We're gonna talk about the specs, and this is the system on the background that I'm using today. And after that, I took it on my iPhone XR, but the desktop resolution is 8K resolution because I was running Battlefield in windowed mode. Why I did it, because pretty much in Battlefield 3 under the Windows 10 Professional, pretty much it doesn't matter, windowed mode or full screen. Some people saying full screen more FPS. Under the Windows 10 Pro it doesn't matter because even the desktop is Direct 3D surface. Keep that in mind if you're using the nice video card under the Windows 10 Pro. So this is, guys, how Titan RTX was running stock, but 100% fan rotation. I didn't increase power limit because we already was thermal throttling. This is the IDA 64 GPU, 2 GPUs versus the CPU, but CPU only with the 8 cores. CPU will score a much higher score with 18 physical cores, and the hyper-threading technology enable up to 36 logical cores per CPU, total 72 logical cores output. Is going to be dramatically higher output, but as again, there is no match for even the single Titan RTX video card. Titan RTX use the OpenCL to render it, and the Xeon E5 use the 64-bit machine code, which is closest to the OpenCL to emulate the same kind of algorithms and scenarios as a benchmark. Okay. If you want to utilize the full bandwidth on the Xeon's E5-2699v3 on this Chinese motherboard, you need to have at least 4 cores and 2 CPUs. It doesn't work with one CPU installed on this motherboard to utilize the quad channel, which is 256-bit for your system RAM. And this is nice, especially if you're building RAM disk and you running the game through the RAM disk and you still recording using the NVIDIA Shadow Play 4K resolution or 8K resolution into the RAM disk. You're going to have a lot of advantage and your video will be much smoother, guys. Keep that in mind when you're recording into the RAM disk versus the hard disk. But kind of crucial, MX500 2TB SSD that I'm using today, SATA 6, is pretty much more than enough. It's like 550 megabyte per second write and read for outputting even Shadow Play recording in 8K resolution in real time. So kind of RAM disk is kind of so. It's only for the scenarios when you need to have 4 or 8,000 megabytes per second data transfer, especially when you have like 1 gigabit internet and you're a server, or more than 1 gigabit. Let's say you have like above 10 gigabit internet and you're a server, then the RAM disk will be great. Then you probably want to install 256 RAM system RAM on this motherboard and use like 220 gigabytes straight for the RAM disk and rest for the operating system, so multiple people can access to your server and get access to those files at very fast time. Okay, so everything is self-explanatory. As again, this is the CPU Z. Let me show it to you. 2 sockets, 2 CPUs, 4 core, 4 threads per each. Okay, 172 gigabytes of quad channel. Here's my Titan, and this is the score. But as again, the CPU is scoring like above 10,000 on the multi-thread. Keep that in mind. So it's beating up the 3950X easy. All right, so yeah. Multi-thread ratio almost 8x, 7.5, great. The higher cores, the less ratio will be, because even the native cores, physical native cores, when it's a lot of them is not acting properly, that's why you want to minimize them for PC games. You only want to use them when you're doing is a workstation. Okay, so we pretty much cool down the CPU. As you can see, 33 Celsius. What I'm going to do, I'm going to overclock my core clock by 1000, and we're gonna run it. Hopefully the recording is not going to freeze out. This is the second time I'm re-recording it because it's freezed out on me. So 1000 additional overclock on the system RAM, which will be outputting to 2000 megahertz of the video RAM, not the system RAM but video RAM, VRAM. Okay, let me go back to the game. By the way, guys, the soundtrack that I'm using today will be let me see, let me zoom out. I'm gonna show it to you. As you can see, I was playing the soundtrack on the Squadra BTV. Squadra B. This is the soundtrack that is used, provided by YouTube. No royalties can be claimed. Beautiful soundtrack. Alright, let's go ahead and have a look, shall we? I'm going to go ahead and show you this. I'm gonna start the checkpoint. The Titan RTX is the first one, is not thermal throttling right now. It's going to be healthy and it's going to be boosting that frequency. This is how you're gonna see it, how you're gonna have it almost when it's going to be water cooled. But I didn't overclock the GPU yet, so it's about 5-7 at least healthy percent of the boost should be. When GPU is overclocked, it's like, and VRAM is overclocked, it's going to be like 12-15% will be maximum when your Titan RTX will go above 2000 megahertz on the GPU. and it's only possible when it's going to be the first video card will be water cooled. Even with the hybrid water cooler, the cheap one, buy the extension for $30 and the Corsair water cooler for like $60, and total will be like $80-$100, and install it on this Titan RTX, and then you're going to go above 2000 megahertz. So pretty much everything what you saw today plus 15% of the FPS boost plus 3 FPS because no shadow play recording. Look at that crazy FPS. This is, guys, the ultra. And when the first Titan RTX is not thermal throttling, is crazy. What I'm gonna do, I will load after this. I'm going to load the first level. We're gonna cool it down a little bit, and I want to show to the Bank 4 Bug PC gamer from UK when the first Titan RTX is not thermal throttling, what will be my FPS. But it's even when it's thermal throttling, I'm beating him by at least 10-15 FPS when he's running Ryzen 5950X and RTX 3090. So there is a possibility they lied to us about the RTX 3090 and 3080. Maybe RTX 3090 is not as fast as two Titan RTXs. It should be, based on what they said, it should be like as fast or hair slower than two Titan RTXs, but it's not the case in this particular game when compared with the data, which is the legit hardware overclocker and reviewer. So we're gonna find out. So what I'm gonna do now, I'm going to go ahead and go to exit to menu, and I'm going to prepare the level for us, and I'm going to quit to cool down the first GPU because it's already almost thermal throttling. Not yet, but it's already started. As you can see, it's lower the frequency on the first GPU by 100 megahertz already. Okay, so what I'm gonna do, campaign, first video. Let's set the video. I need to set the video like he had. So what he had, he didn't have no motion blur, no anti-aliasing, just like I showed you when it was thermal throttling at the beginning, but without it. And he has the ambient occlusion all the way to HBAO, like that. Apply, save it, and pretty much this is how he showed it to us. I showed you already like that on that level, but it was thermal throttling and without the VRAM overclock. So let's go ahead and get going. Guys, keep in mind when I'm overclocking this video cards in SLI mode, during this condition, they're freezing after 20 minutes because they're just thermals. Those temperatures are too hot. Replay missions, okay, and not the hunting, but the operation sword breaker. And I'm just going to start the level, pause it. We're gonna get back to the desktop real quick, just real quick for less than a minute. I'm gonna cool it down to 30 Celsius, 35 Celsius on the GPU of video card 1, and we're going to come back. So like over here, I'm gonna go ahead and pause. Come on, load up. Almost, here we go. So I'm going to go ahead and pause that. Here we go. And what we're gonna do, we're gonna minimize it and wait a little bit. We're gonna chill just 20 seconds. Look at that, how temperature is falling down. Tune, 47 Celsius, we're already 46. I'm afraid to overclock the... Let me go ahead and overclock the GPUs, but if it's going to, guys, freeze up, keep in mind that this is synchronized, as you can see. So when I'm adjusting this through the MSI Afterburner, you want to make sure that it's synchronized. Over here is checked. Synchronized setting for similar graphic processor, so you're adjusting it for both GPUs, but at GPU 1 is our hottest GPU. So I'm going to overclock it too. So I'm going to say, hopefully it's not going to freeze up on us. I'm going to say plus 90, okay, and we're gonna save it. This is a great kind of for SLI. Otherwise I'm running like 100, 120. So plus 90, 38, so doesn't want to 37, so it's kind of cool. A little bit longer, guys, and come on, 36, and I'm gonna jump in. So hopefully it's not gonna freeze, but we're gonna see that FPS. For those folks who's curious, this is an extra bonus. Don't forget to smash that like button. What if both video cards will be water cooled, or what if the first one will be on a hybrid water cooler for $100 of investment, which is the best. Do not set your video cards on full water cooling. It's just waste of money and time. After 2 years, you're gonna build yourself, or 3 years, new computer, and you're just gonna waste that $1,000 towards the water cooling. Doesn't make no sense. Buy cheap water cooling hybrid setups, and you're gonna be Gucci. All right, guys, I'm jumping in. I'm jumping in to the battlefield, and here we go. 110 FPS almost. So we improved by about 6 FPS. We started like what, 102 when I was running, when it was thermal throttling. 108, solid. Below 10 milliseconds latency. This is amazing. Below 10 milliseconds latency is amazing, but below 5 milliseconds, it's just like wow. It's like out of this world. It's like to the Mars, to the moon. Beautiful, guys. Amazing performance out of the NVIDIA Titan RTX SLI, and this is the last mammoth that is possible to run in SLI, because RTX 3090 video cards doesn't support DirectX 9, DirectX 10, or DirectX 11 in SLI. It only supports DirectX 12 multi-GPU ability and Vulkan and OpenGL multi-GPU ability. Okay, but it must be programmed by the developers for that game engine, and developers, those game developers, are lazy, and usually they don't do that stuff. Okay, guys, it's just beautiful, and it's not stuttering. Keep that in mind. Maybe it feels like so, but this is because I'm running on low on battery on my mouse, and my mouse needs to be battery replacement. I can already feel it, but it's not stuttering. I played it yesterday, guys. I enjoy it 8K resolution, even enjoy it in 16K resolution. 16K resolution, guys, maxed out above 30 FPS. You don't want to miss it. And boost out of the single Titan RTX will be 1.9 times at least. You don't want to miss both videos. Single Titan RTX in 16K resolution in Battlefield 3, and 2 Titan RTX video cards in SLI, in NVIDIA 2-way SLI in Battlefield 3. Look at this. Above 90, and he was bank for Bach PC gamer from UK was like over here was below 80. I'm like 20 FPS above him. If this is the case, I don't think this is because my CPU is better. It's definitely not, even in the PC gaming for sure. But this is because his RTX 3090 is not close to 2x of the Titan RTX of the Turing. It's probably 2x RTX 2080 Ti, but it's only 10-15% slower, so it still doesn't make no sense. So it's even slower than 2 RTX 2080 Ti then, at least in Battlefield 3 based on his data. I'm gonna contact him, guys, let him know as well. We're gonna find out what's going on. Maybe we can do the co-op together. That Bank for Bach PC Gamer is core of the 7 YouTubers. That was the second wave of the hardware guru enthusiasts and overclockers. It was UHD King, which is me, Tori IR, Bank for Bach, Xavier from France, and some German overclocker, I forgot his name, and Sloppy back in 2015/2017, and Bank for Bach PC Gamer started like in the, I believe, middle of 2017. But this is the core, or second wave as I call, of YouTubers after the first ever enthusiasts on YouTubers. So we one of those guys, and Linus one of us, and then J2 Cent, and the other guy from California and his buddy Kyle. I forgot that his name. This is, guys, the pretty much the best legit YouTubers review PC hardware or PC overclocking. Alright, guys, so you saw, guys, let me quit. look, above 100 FPS when it's overclocked in 8K resolution, ultra. You know what I'm gonna do, guys? What I'm gonna do? Simple. I'm gonna cool it again. Let's do it because it's simple video, right? An extra 5 minutes, but we're gonna cover everything. So what I'm gonna do, let me cool it down. So it's 86. I'm gonna turn down the ambient occlusion, HBAO, and you're gonna see it's going to be crazy. We're gonna turn it down. So this is the HBAO on. As you can see, it's creating that extra around the edges of the every single 3D mesh. It's like inner shadows in Photoshop. Boom. Okay, let's go ahead and do that, and we're gonna try it in a second when I'm gonna cool down the first GPU on the first video card. So I'm gonna click apply, save that. Let's minimize it. Wait like 30 seconds. This is the CPU utilization right here, guys. Everything is closed. In the background, nothing is running. So as you can see, we have plenty to go. And when your CPU utilization below 90%, as again, you don't need to add additional cores. You're Gucci. If you're going to add additional cores, you're going to lose in terms of the latency communication CPU with the memory, and latency of each core of the CPUs will be higher. Okay, when more cores are added, because look like less cores are faster. They're acting faster somehow. Even in 2021, maybe in the future when they're going to do 3D layering cores, it's going to be different. But even in 2021, this is the scenario, and this is the scenario was like since 2005 when first core to dual core by Intel CPU was introduced by Intel. But AMD was also X2. They were first. They were much faster than Intel did back in like 2005. Alright, so 39, almost there. I'm just waiting 37 and I'm gonna jump into the game. And then maybe I'm going to show you the online, for those who's curious, an extra bonus, as again another extra bonus. So don't forget to smash that like button. So 37, let's go ahead and jump in. So what I'm gonna do, I'm just going to restart the mission. Okay, let's see. It's probably going to be, guys, like, oh my god, oh my goodness. Let's see. Come on, give us like 150, 160 FPS in 8K resolution at ultra preset without the ambient occlusion and without the anti-aliasing, and I'm gonna be a happy camper. Nope. But 133, 134. Compare the same test that we did while the Titan RTX was thermal throttling. Just go in the beginning of the video, and watch that video. 133 FPS, amazing, guys, about 120 FPS. That latency delay way below 10 milliseconds. Alright, GPU is thermal throttling, it's fast thermal throttling, check it out. Already lost 200 megahertz, 76 Celsius. You can see by this video when the Turing GPU architecture started thermal throttling, and so pretty much you can analyze it and understand it. If you want to invest at least $100 towards the hybrid water cooler, or it just will be like that. But if you're running SLI, if you're running single video card, I would not invest into a hybrid water cooler, even if you into the overclocking, because maximum boost will be like, you can see that Slappy, it was my mouse, it's on low on battery. Maximum boost, guys, will be 15%. Why you want to do it? For extra $100, invest another $200 and buy a better video card. But for the SLI, when you're running 2 video cards or more, most definitely you need to have the first video card on the hybrid water cooling. Otherwise, you're gonna lose some FPS. You're gonna lose about 10% of the performance. Alright, so we're thermal throttling now, so pretty much we don't need that. So let me go ahead and quit this. I'm gonna quit this, and we're gonna start with multiplayer. Let me load up the multiplayer. Play. Here we go, multiplayer. Let's load the Caspian border, which is the large map with a lot of players on it. Or maybe this one right here is going to be nice. 61 people playing. Yeah, let's go ahead and join this one. Let me add as favorite. This is going to be Infest, 25 ping. Alright, let's go ahead and load up. Let's see. I'm loading up the multiplayer map. Guys, this was with the Origin on the background. And Origin user interface is based on a DirectX 11, and this is a big mistake. Origin user interface shouldn't be based on the DirectX 11 because there is no animation, there is no need for it, but it's utilizing about like 5, sometimes even 10% of the GPU, especially when you're running in SLI. So that's why our GPUs was not utilized all the way fully, but the SLI utilization was excellent. If you're gonna find a way how to run Battlefield 3 without the Origin, it's going to be 97-99% per each GPU when you're gonna run 2 Titan RTXs or 2 RTX 2080 Ti and SLI. Okay, so alright, let's go ahead and jump in, guys. This is maximum overclock online, and a lot of players playing. 140 FPS, 8K resolution. Look how beautiful everything looks. Wow, that's just unbelievable. Let me jump into the tank. Abram, we're gonna go ahead and try to play this game well. I really like the Battlefield 3 PC game because it looks so photorealistic. Battlefield 4 also great, but after Battlefield 4 they just lost that thing because they were hiring people that don't care about the company. They were caring about their families, kids as excuses. Do not hire those type of people, and making money. You want people that would like to make money but would like to make a difference. You want to have those special champions. Guys, is running so solid, loving it. Above 100 FPS, 8K resolution in Battlefield, ultra preset, as again for naysayers. Before we're gonna get killed, let me show it to you. This is our preset, guys. Alright. Running so fast, running from the SSD, not from the RAM disk. RAM disk will be even faster. But you need to have a RAM disk only for the scenarios that requires the RAM disk. Like 8K resolution, 60 FPS, running almost uncompressed. Or something like that requires that per second a lot of gigabytes data transfer, or like above 550 megabytes per second. If your data transfer must be above 2 gigabytes per second, then you need to have RAM disk, because there is the fastest storage that is available in 2021 that will cost you like thousands of dollars. Oh, I disabled that guy. Alright, I disabled him again and I killed him and he killed me. Anyways, this is not the video about the gameplay. I didn't play the Battlefield Online for a long time. But if you're professional, you can even play with this user interface. But you're not going to see the map. So if you know how to play without the map, you're going to be Gucci. Guys, that's it. That's all. We got it, guys. I mean, I showed you everything what you need to see. Hopefully you enjoyed that. And look at this. In the Battlefield 3, actually in online, we were utilizing more CPU. Alright? So, yeah, 8 cores probably will be for 8K. Because 6 core for the online is not going to be enough, because as you can see, we almost was bottlenecking the 8 core. We still have some extra to go, but if I'm going to add 10 cores, we're not going to boost up in terms of the FPS. We're just Gucci with the 8 cores in Battlefield 3. Battlefield 4 is utilizing like 1 more core more utilization requirements for the in Battlefield 4. In Battlefield one, 8 cores will be utilized, and for sure. And if you're gonna have 10 cores, you will be Gucci. But in Battlefield 5, in 8K resolution, 10 cores is fully utilized, guys. Okay, almost like to 90% on 10 cores. That means that 12 core for you to be without the CPU bottlenecking in needs of cores will be Gucci. Alright guys, that's pretty much it. Go ahead and smash that like button. Right now I'm putting some great videos for you to watch. Hopefully you're gonna have a great morning, great day, great evening. Share it with your friends. I play 4K, aka I play 8K, aka I play 16K, or UHD King. Till the next time.